In this video, we're going to learn how to use the slicing method to determine the formula for the volume of a cone. So if we have a cone that is lying along the x-axis so that its pointy end is at the origin 0, 0, there we go. Beautiful cone. Okay, x-axis. And let's say that it has, so here would be the diameter. And so it has a height of h. And it has a radius of r. We know that to find the volume, we have a formula. The integral from a to b times the cross-sectional area, a of x, dx. So the question always is with the slicing method is how do we find the cross-sectional area? Well, to do that is a little trickier than with a cylinder, which is what I did in my previous video, because in this case, the radius is constantly changing. The radius is going from capital R all the way down to a radius of 0 when you get down to the pointy end. So we're going to use similar triangles here. I am going to make an arbitrary radius right here, small r, and this distance from here to there will be x. We can then say that little r is to x as capital R is to capital H. So using the proportionality there, similar triangles. Solving this for little r, we have r is equal to capital R x over h. So that means we can determine the radius for any value of x. Capital R and capital H are constants, they do not change. But as x changes, r will change, and so we can find the r value for any arbitrary value of x. Well, because the cross-sectional areas here, when we do the slicing method, the cross-sectional areas are always going to be a circle. So it's going to fit into the form pi r squared. But r is constantly changing in relationship to x, so we can take r and we can put in our little formula for r, which is capital R x over h. And we want to square that. All right, so there is our formula for the cross-sectional area. Now all we need to do is to set up our integral. And so the integral for volume will be from 0 to h. Those are our bounds of integration. The cone extends from 0 to h along the x-axis. And we have our cross-sectional area is pi capital R x over capital H squared dx. Well, before I integrate, let's get rid of the constants. So r is a constant, h is a constant. We're squaring them both. Pi is a constant. So volume is equal to pi r squared over h squared, integral from 0 to h, x squared dx. So this is very easy to then integrate. Integrating this, we will have our constant, and then 1/3 x cubed, and that is all being evaluated from h to 0. Well, the 1/3 again is a constant, so I'm going to bring that out with the rest of the constants. So I have 1/3 pi r squared over h squared, and then doing the fundamental theorem of calculus, we have h cubed minus 0 cubed, which of all just becomes h cubed. So the volume is 1/3 pi r squared h cubed over h squared. And of course, h squared cancels with all but one of those h's. And we get our final answer, 1/3 pi r squared h. And that would be the formula for the volume of a cone. And you can look that up in Google. That is a standard geometry formula. Now, if you wanted to find the volume of a specific dimensioned cone, all you need to do is plug in r and h, and there you have it.